Hi, this is Gigi Petrali speaking from Whirlpool. I will talk about this project, which has a very important name because it's a name of an important musician, but it's actually also an acronym that stands for Robotic Enhanced Sensing, Intelligence, and Actuation to Improve Job Quality in Manufacturing. Of course, let me just spend a couple of words about my company. I hope everybody knows Whirlpool. Whirlpool is the leader in the world on white good appliances. We're employing more than 77,000 employees around the world. And last year, we make total revenues of approximately 20 billion. We are present in almost all the continents. We have also a strong presence in Europe when we had our European, Middle East, and Africa headquarters based in Italy. We have production facilities in Italy, a lot of them, in Poland, strong presence there, in Slovakia, in England, in Russia, and in Turkey. What are we doing here in Europe is not much different from what we are doing all around the world. We are producing and selling products for the kitchen, so ovens, refrigerators, cooktops, dishwashers, and also products for the laundry, so washing machines and clothes dryer. Here we can see three of our most important brands we have in Europe region. So Whirlpool is very known. Indesit is the one that we heritage when we merged with the Merloni group some years ago. And there's also maybe something that is not so known in the big, large population is that KitchenAid. So also those fancy stand mixer, and other small appliances is also a part of the big Whirlpool family. Okay, let's skip on the main subject of our presentation, which is Rossini. Rossini is a project funded under Horizon 2020, which is the European most important program for research and innovation. It is bringing together many partners. We have some universities, we have some technology partners like Datalogic, like Builds. We are a research center like Fraunhofer, and we are putting together some industrial end user like Whirlpool, like Schindler, like IMA, to test what? To test a novel approach to robotics. The main goal of Rossini is actually to develop a very innovative way to design and develop robotic cooperation. So our idea is to make sure that the future cooperating robot will be inherently safe, providing both software and another platform. With the goal, the final goal to have a system able to spread the human robotic cooperation application. Of course, to do what? To increase job quality, so to improve somehow the condition of work of a worker, and also to let more flexibility in production schedule and production management. And that's, of course, is also helping the way in which Europe is going to evolve their approach toward future manufacturing as manufacturing. The main goal for Rossini will be achieved through the development of a single platform, I say. A single platform which is getting together different layers, what we call layers. So there are many layers that we can put together in order to achieve the goals of a human-robotic cooperation. We have to talk and to take account the sensing, the perception, the cognition, the control, the actuation, and of course, the human factors, and putting all together, so integrate them in one platform. Let's see what are these sensing, perception, and cognition meaning. Why sensing? Sensing is, of course, the act to gather some information, or better, some data from the field. So in our projects, the goal is to improve the detection capabilities of those systems, to improve the track capabilities, and to monitor the working environment, and of course with a special attention to the safety related issues. Data alone are doing anything. We need to transform this data into information. So the idea is to fuse all this data into a perception layer, which is able to transform the raw data that we have into what we call the semantic scene map. So the idea is to understand what we are actually immersed. So the idea is to make sure that the robot is able to understand which are the environment is immersed into, in terms of space, in terms of people, in terms of products, and all the other things that are there. Of course, it's not enough. Once we have the information, we need to generate also some knowledge behind it. So the idea is to fuse together all this information gathered from the sensor and to make sure that we have some basic platform of available information to, for example, generate scheduling, to plan activities, and to update the working environment through this availability of semantic scene map. Once we have the cognition available, we are able to make the control. So to plan task planning, to plan actions, and to plan the way in which the robot has to move in this new enriched environment. And of course, once we have the capability to generate an action, we need also to place into place. And so we did the actuation layer. Rossini is going to develop a robotic arm range, new safety features, so to reduce separation distance and also to improve the way in which human and work can work together, share the same area, share the same space, and share the same actions. The human layer is very important in this approach. Why? Because, of course, the main hurdle we have is for making robot working with humans is to let robots safe, able to understand, able to cooperate. So it's very important that all the human factors is understood and taken into our platform. We need to fuse all these things together because we can have a lot of sensing, we can have a lot of software, we can have a lot of different parts, but the point is that we need to put together so that we're able to generate one single platform to put all these things together and allows for efficient and also effective robot and human integration. Of course, there are some challenges to reach that. First is safety. Safety is the most important part. As said, we need to make sure that the human is not going to be harmed by working with robots. And that's very hard to be done when we are talking about robots which are moving or, let's say, working with heavy payload. So one thing is for a robot to move one screw or very light objects. Another one is cooperating with the robot, which is moving very heavy load, like we will see in our use case, a counterweight for a washing machine. Also, the second big challenge is that it's not the robot itself that has to be safe. It's the whole application. So an example that usually I told to the conference that I can have the safer robot in the world, but if I place a very katana or another kind of sword in their effectors, it's very difficult to provide an overall safety. So it's very important that we are addressing this aspect in overall system-wide aspect. The third challenge is to make sure that the workforce, so the people, is going to accept to work close to a robot and share space, share action with him. So also this is a thing that we need to work a lot and to make sure that all the technical achievements we are doing will be accepted by the human being. So here we show how Rossini is planning to provide answer. Let's step into how Whirlpool is going to test that in their approach. We place a business case, which is actually based on a typical situation we have in our washing machine production line. In washing machine, there is an object, which is the counterweight, which is pretty heavy. So it can weigh from 10 to 14 kilograms, and currently is managed by a human worker. In keeping it, sometimes it is assisted by a zero gravity tool, so a sort of you can here see in the animation up front, just to relieve some the weight load. But at the end, we have to let the worker trust in their hands, in their arms, in their strength to assemble it. Of course, this is not a very good operation from the economic point of view. So we are asking a lot to the worker. And you can imagine to do that 8 hours a day within a cycle time, which is more or less 22 to 30 seconds for each piece, depending on the production line. So we want to implement a robotic cell in this workstation. How to do that? The invasion solution is to make sure that we have a robot that can share the same area, so can work together with the worker and let all the operation, not ergonomic, so taking the counterweight and placing close to the machine, let's do it to the robot. This is simple. It's not that simple to be done, especially for the fact that in order to have to load an heavy weight, we need also to work with a heavyweight robot. So it's not a collaborative. It's not easy to make collaborative this. Which are the objectives that we have? Of course, improving safety and ergonomic aspect. This is the main goal for having cooperative robots in our factories. It's not always an economic point of view. The real objective is to make sure that our workers can work in a safe condition and without any risk for their health. So the idea is to achieve this kind of new working cell. This project started a couple of years ago, and now we are very close to its realization. What we did is, of course, to use a lot of 3D models and advanced simulation to put together the novel work cell. Here you can see an animation of it. Take into account that we have to work within a continuous production cell, so it's in another factor of difficulty. The robot has to synchronize with a moving assembly line and share the same spaces with the worker. The idea is that, okay, now you cannot see the worker moving, but in the real situation, the worker will be then addressing the washing machine to do other operation of cabling, screwing, and so on. How to do that? Of course, you can see just a robot moving here. Behind that, there are some novelty things. So all this cell is integrated with some very advanced mechanism to control. A lot of cameras that are getting the scene and translating it into semantic paths. So the core of the system is this ROS semantic layer controller, which is based on vision system, which is constantly keeping the imaging from the environment and the worker and using it to communicate with the robot. So the robot behavior is controlled by this continuous information about the scenes. Also, we need to make sure that all the cell is synchronized with the production, and this is the way in which need to do that. So all the system is synchronized with the actual production. And also the system has to be synchronized with the part entering. So it's very important that also there is a vision system able to recognize the counterweight. The safety is the basic thing, and this, I think, the very novelty matter within Rossini. So all those sensors are communicating each other, and as you can see here, we have a lot of sensors, not only cameras, but also some skin sensor on the robot. And arm resolution camera, body resolution sensor, and skin are cooperating within those two blocks, which are pieces of software, which are then able to communicate action to the robot. So the robot is actually working, taking into account what is happening to the people, to the body, what is happening to itself, and what is happening in the environment. We are so trying to put it together, as I said, a lot of cameras, a lot of sensors, and that's not an easy job. It's enough, not enough, because I'd say before, the application has to be safe up to the application layer, so up to the end effector. So besides of doing that, we also had to design a specific gripper that has to be collaborative by itself. So we put together a novel design, we are build them, and we are going to equip this gripper with some further camera sensor able to see the parts, and also the environment, and also this new soft skin concept. So the idea is to keep the gripper with a software as for the human, a skin able to sense some touching, and so to react quickly whether the system, in this case the gripper, is going to touch the operator. So, conclusion. The real challenge for the future is to make sure that any robotic application will be cooperative, no matter about the size of the robot, no matter about this velocity, no matter about that. The real challenge is to make for every robot in the future being able to cooperate with human. This could be achieved by this integration of sensor, artificial intelligence, and also, of course, actuators. The other interesting conclusion we are having within this Rossini is that we are designing everything using 3D models and simulation. So there will be no physical prototype realized unless we are completely satisfied with the digital design, which is, of course, helping us to reduce a lot the money used to make physical prototypes, and also the time. The third important lesson is that end effectors are very important. So it's not enough that we are able to design a robotic arm which are cooperative, but also the end effector. So while we have a lot of robotic arm able to be cooperative, it's not the same for end effectors. Very often end effectors have to be designed for the custom needs, because parts are different and so on. And so I think that in the future, what we are asking for is, what you're looking for, what you're hoping for, is to have some more standard application helping us to reduce time and effort and also money to design the customized grip. Saying that, I finish my speak, and I will be available for question and asking for details in the future session. Last things, I will invite you to join the Rossini Project website, where we are some more advanced information. And also, I'm available to be reached by email in case you want to have some more information about the project, or you want to exchange some ideas and comments with me. Thank you very much.